Hey everyone. So this is the second lesson about mechanical waves, and today we're talking about their properties. Okay, so we're describing the waves, what they look like, certain features about them, how they interact, and so on. So what we're going to be talking about today, or some of the properties that we're going to talk about today, are 5. So something called the periodicity, the frequency, the wavelength, the speed, and something called the amplitude. So we'll talk about each one in detail. So number 1, the period. Okay. So if you've ever seen people who surf, I'm sure you've seen those on TV and some of you have tried it. Surfers know how to catch the next wave by counting the time between two crests of the wave. The crest, remember, is the highest point of the wave. So that if they count the time between each wave, they can predict when the next wave is coming, and then they can catch it. So any motion that repeats at a regular time is called a periodic motion. That means it's repeated in a regular way. Okay? So the time required for one cycle, a complete motion that turns to its starting point, is called a period. So from the starting point of the wave till it ends is called one period, and then it starts again, another period, and then it starts again, another period. Okay? So for instance, in the ocean wave for the surfer, the period is the time between the two crests, between the two top parts of waves. And of course, they have to be successive. The word successive means after each other, so you can't skip one. Then it would be the period between them. Okay? Or the time between them. Now, the second property that we're going to talk about is something called the frequency. So, how often does this periodic motion happen? How often? So, how many cycles in a certain given amount of time? So, per minute, how many cycles or how many waves per second, how many waves, and so on. That's called the frequency. So, how often it happens. Okay? So, the frequency, the definition, is the number of wave cycles that pass a specific point in a certain given amount of time. Okay? We measure the frequency in something called hertz. So hertz is basically cycles per second. So if we calculate it per second, then the unit becomes hertz. So how many waves in 1 second is hertz. Okay? So if you look at the rope here, the rope has a transverse wave because it's moving up and down, and the wave is moving in that direction, or maybe that direction, so they're perpendicular. So this is the resting point. Remember, this is the crest and this is the trough, and that's the resting point. So if there's only 1 cycle per second, so every second there's 1 wave, that means it has 1 per 1. So 1 cycle per 1 second equals to 1 hertz. If in 1 second, for instance, there's 2 cycles, so every second there's 2 cycles, that means it's 2 per 1 second, that means it's 2 hertz. Simple. Okay, so it's just how many cycles per second, and the unit becomes hertz, which is represented as Hz. Okay? You may have heard the word hertz, when you listen to the radio, it says Nal FM 104.2. That's hertz. That's the frequency. Okay. Other channels will be, 94 point something. That's the frequency. 98.8. That's the frequency. Okay. All right. So we're now going to talk about the third type of properties. Okay. So this is the wavelength. So from the word, it's the length of the wave. Okay. So the length. So it's distance between a point on one wave and the same point on the other wave. Meaning, from crest to the same point, that means crest, or maybe from trough to trough, or from resting point to a full cycle of the next, well, maybe not the resting point, because it might confuse you. That would be a half wave. So anyway, from crest to crest is 1 wavelength, is the length of 1 wave. From trough to trough, it's the length of 1 wave. That is if, of course, I'm talking about transverse waves. Okay, so from crest to crest here is 1 wavelength. From trough to trough is 1 wavelength. What about longitudinal waves? Okay, so we'll say from compression to compression, or from rarefaction to rarefaction. Okay, so from compression, because it goes from compression to rarefaction to compression. So from compression to compression is 1 wavelength. Okay? So again, for transverse, it's either between crests or adjacent troughs. Adjacent means next to each other. You can't, again, skip one. Okay? But in the longitudinal, it's between adjacent compressions or adjacent rarefactions. Okay? Length, it's distance. So the units are meters. Yeah? The standard unit is meters. Okay? So, let's say, for instance, that this is a long wavelength compared to this is the short wavelength. If you can see, the distance between the crest and the crest here is longer than the distance between the crest and the crest here. So that means this has a longer wavelength than this one, and this one has a shorter wavelength than that one. Okay? Now, obviously, wavelength and frequency are related because here it's less frequent than here. Here it's more frequent. You've got more waves per second, right? So there's more waves, more frequency. So the more the waves in the same amount of time, that means the wavelength is shorter, logically speaking. Okay? The less the waves in 1 second, so the less the frequency, the longer the wavelength. So they have an inverse relationship. Inverse means the opposite. So the longer the wavelength, the less the frequency. The shorter the wavelength, that means there's more frequency. See the opposite. When I say long, it's short. And when I say short, it's long, and so on. Okay. The fourth property that we're going to talk about is the speed. Now, if you remember, speed is basically distance over time. So what is the wavelength over a certain period of time? So you can either say wavelength divided by period. I just said it. The length over a period of time. So you can calculate the speed of the wave by the length of the wave in a certain amount of time. But because we know that there's a relationship between the wavelength and the frequency, which we just talked about here, okay, there's another way to calculate it, which might be more straightforward, which is to calculate the speed, we'll say the wavelength times the frequency. Now let's talk about units for a minute. We said the wavelength is measured in standard units of meters. And the frequency, the standard unit, is hertz. If this is meter and this is hertz, then the speed becomes meter per second. If any of that changes, it changes the units. Okay, so it's best in this case to change, if you get a unit that's less than meter, to transfer it to meter, or bigger than meter, to transfer it to meter, and then calculate, because the frequency in hertz is in hertz. So for us to get the speed meter per second, we have to use these units: meter, hertz, and meter per second. Okay, so we're going to do some math as usual. So if it says one end of a rope is vibrated to produce a wave with a wavelength of 0.25 meters, and the frequency is 3 hertz, that means 3 cycles for every second. So what's the speed? Now the wavelength is 0.2 meters. The frequency is 3 hertz. The units are great. They're fine. They're the ones that I like. So we'll just use the standard formula that we just talked about. Speed is equal to wavelength times frequency. So I'll just substitute as usual. So 0.2 and 3. So my speed will be 0.75. And don't forget the unit. You always lose points for units sometimes. Meter per second. Okay, let's do another one. Very straightforward, very easy. If the wavelength is 2 on a rope, and the frequency is 2, what's the speed of the wave? Very direct, that's 2 and 2. And the formula is wavelength times frequency, so 2 times 2 is equal to 4, remember, meter per second. Always pause when I do these math problems, try to solve them on your own, and then see if you got it right. Let's do another one. A motorboat is tied to a dock with its motor running. The spinning propeller makes a surface wave. Doesn't matter what type of wave, okay? It has a frequency of 4 hertz and a wavelength of 0.1 meter. What's the speed of the wave? So the wavelength is 0.1, the frequency is 4, so the speed is wavelength times frequency. 0.1 times 4 is equal to 0.4, again, meter per second. Now, they might start switching things around, so let's see the next one. Now, if I use the other formula that we talked about, which is speed is equal to wavelength over period, which is the normal distance over time. Let's see what he wants this time. What's the speed of a wave in a spring? Again, this is a longitudinal wave. If it has a wavelength of 10 centimeters and a period of 0.2 seconds. Okay? So that's how long the wave lasts. So I have the time. So in this case, I'll just use this formula, not the other one. I won't say wavelength times frequency because he didn't give me frequency, but he did give me period, so I'll say wavelength divided by period. Now the wavelength, if you notice, he said 10 centimeters. It's not meters. So I have to convert it to meter. So 10 centimeters is 0.1 meter, okay? And the period is 0.2 seconds. It's in seconds, so that's great. Okay, so I'll say wavelength divided by period, which would be 0.1. Remember, don't use 10 because it's centimeter, it's meter. 0.1 over 0.2 seconds, and the answer is 0.5, again, meter per second. Okay, one more. What's the wavelength of an earthquake if it has a speed of 5 kilometers per second and a frequency of 10 hertz? Now this time, he's switching things around for us. He gave me the frequency, 10 hertz, and he gave me the speed. But if you've noticed, he gave me the speed in kilometers. So I have to transfer kilometers to meters. So then it would be, kilometers is 1,000 meters, so it would be 5,000 meters per second. Now I can start working. So it's speed times wave is equal to wavelength times frequency. I have the speed and I have the frequency, but I don't have the wavelength, which is what he wants. So I'll just substitute first. So the speed is 5,000 and the frequency is 10. So then the wavelength would be equal to 5,000 divided by 10, which would be 500 meters. Now the unit here is very important. Because this is standard, we should use the meter. But sometimes he'll say, because he gave it to you in kilometers, convert it back to its original thing. So how much would 500 meters be? It would be 0.5. Actually, it's 0.5 kilometers. Okay? All right. So more on the speed. Now, something happens when a wave passes through a new medium. So for instance, light travels in waves. If light is passing through air and then it hits water, the medium is different. So it might actually slow it down or speed it up, depending on where it starts and where it ends. So one of the things that will affect the speed is the change in medium, okay? Also, if there's a change in pressure. So if you go from an area of low pressure to high pressure, it might slow down. If you go to the opposite, from high pressure to low pressure, it will speed up. Same thing for temperature, because if you remember, temperature and pressure are related. The higher the temperature, the more the pressure. The lower the temperature, the less the pressure. So what are the things, again, that could change the speed of a wave? It's if it changes mediums, so the state of matter changes, if there's a difference in pressure, or if there's a difference in temperature. Okay? Now, remember, the wavelength is inversely proportional to frequency. That means when the wavelength increases, the frequency decreases. If the wavelength decreases, the frequency increases. Okay? So the wavelength with a lower frequency, lower has a longer wavelength. It's the opposite. Okay. Now, this is the last property. It's quite easy, actually. It's something called amplitude. Basically, amplitude means how far does it go from the resting position. So if it's a transverse wave, how far from the resting position does it go up? Or how far does it go down to a trough? So how far away? So it's always a distance from the resting position to the crest or the resting position to the trough. Obviously, if this is a longitudinal wave, it'll be from resting position to compression or resting position to rarefaction, okay? So the definition is the maximum, the farthest that it can reach, the maximum displacement. That means how far did it go off from the resting position of the medium, in this case the rope, or in a wave in the ocean would be the water. As it goes, the highest point would be the crests from the resting position. Okay, so again, the amplitude is the maximum displacement, how the farthest it can go of the medium from its resting position. Now, the more energy it has, the higher it will go, or the lower it will go. And in a longitudinal wave, the farther it will go back and forth. Okay? So the more the energy, the more the amplitude. The less the energy, the less the amplitude. If you want the rope to go higher, you give it more energy. If you want it not to go so high, you'll give it lower energy. So in this case, for instance, the amplitude is high, and in this case, the low amplitude is half of this one. Okay? So high amplitude, low amplitude. Okay? Depending on how much energy. The more energy, the greater the amplitude. The less the energy, the less the amplitude. Okay. So, as you can see, we said it's the maximum displacement from the resting position to the crest or to the trough. Okay, and in a longitudinal wave, it's the maximum displacement from the rarefaction to the resting point or from the compression to the resting point. Okay? All right. So just to revise, this is the wavelength between the crest and the crest, or the trough and the trough. The amplitude is from the resting point to the maximum height, either the trough or the crest, different obviously in longitudinal wave. There's two expressions here that I haven't talked about, but we will be talking about in the next lesson, which is something called the antinode and something called the node. The node is the point at the resting position, and the antinode is the maximum displacement. We'll bring that up in the next lesson, so don't worry about those. But for now, just remember the wavelength, the 5 properties, which is the period, the frequency, the wavelength, the speed, and the amplitude. And that's it. Easy peasy. I hope so. Hope you've taken some good notes.